Okay, in this video today we'll talk about two things. We'll talk about the modulus of a complex number, and we'll also talk about division. I'll do division first, I think. So, it's still in green. I'll just change that because I don't like that colour particularly. Let's have a look at division of complex numbers. Okay, first, division of complex numbers. First, let's just quickly talk about what happened when we had something like this, when we have surds like this and we don't like surds on the bottom line. If you remember how to rationalize the denominator here, it will be very useful to you figuring out complex numbers. So what did you do? We remember that, that because a squared minus b squared, you can be factorized like that. We use this fact to create a conjugate. Okay, so if you multiply a plus b by its conjugate, you end up with a squared minus b squared, which rationalizes it because you're squaring the root here. And so what we do is we multiply by 1, oops, not 1 plus, we multiply by 1 minus root 3 and 1 minus root 3, and that's how we do it. We multiply this by its conjugate. Okay, we just change that plus to a minus or a minus to a plus, and what that does is you get a squared minus b squared, so you get 1 squared minus root 3 squared, and you end up with 1 minus 3, which is negative 2, and so that becomes rational. And basically with complex numbers we do the same thing. We don't like a complex number on the bottom line. If we want to write this out as something nice, then we do exactly the same thing. Let's do exactly the same thing. Let this be our first example. Okay, how do we do this? We multiply it by its conjugate. Okay, so let's multiply that by its conjugate, 1 minus 3i. Okay, 1 minus 3i, and it's exactly the same that happened up here. Okay, so let's multiply the top line. What's 3 times 1 minus 3i? That's 3 minus 9i. Okay. On the bottom line, I'll do it the long way for the first time, but you'll see it's just a squared minus b squared. Okay, so let's multiply it out. 1 times 1 is 1. 1 times negative 3i is negative 3i. 3i times 1 is positive 3i. And 3i times negative 3i is negative 9i squared. Okay. That's 3 minus 9i over, that cancels out, that cancels out. Negative 9i squared is positive 9. Okay, so that's 1 plus 9, which is 10. Okay, and if you wanted to write that out as a nice little one little complex number, it's 3/10 minus 9/10 I. And that's how you divide complex numbers. When you've got a complex number on the bottom line and you have to write it out as a plus bi in that form, then that's the way we do it. We use complex conjugates. And in general, if you've got a complex number z, which is a plus bi, then its complex conjugate we write as z bar. We put this bar above it, and all it is a minus bi. Okay, so if it's 3 plus 4i, if z's equal to that, then its complex conjugate is just 3 minus 4i. If z is equal to negative 2 minus I, then its complex conjugate, all you do is you reverse the complex part, so negative 2 plus I. So that's how we find the complex conjugate, as easy as that. Beautiful. So let's just say z is equal to 2 plus 6i. Let's say you're asked to find z plus I, the conjugate of z plus I. Okay, so firstly let's find what z plus I is equal to. Z plus I is 2 plus 6i plus I, adding an I to it. Okay, but we want the complex conjugate of that, so I'll keep going. 2 plus 6i plus I, that's 2 plus 7i, and we want the conjugate of that. What's the conjugate of 2 plus 7i? 2 minus 7i. There you go, that's the answer there. Excellent. So that's all about conjugates, and that's how you divide by complex numbers. I'll just do one more example of that. It's probably a more technical example when you've actually got two complex numbers, something like that, and let's I don't know, 1 minus I, something like that. Okay, let's do this division. What do? We multiply by its conjugate, 1 plus I. 1 plus I, like so, equals. Let's multiply the top line. It's going to be a bit messy. Let's do it. 2 plus 2I plus root 3I plus root 3I squared. So that's our top line, just multiplying using FOIL. Okay, if you put the brackets there, it might be a bit easier to see for you, for FOIL. And now down the bottom, remember, it's just, when you're doing this, you don't have to really use FOIL because it's always the same. It's just the first term squared minus the second term squared. Okay, so it's going to be 1, and what'll that be squared? 1 minus 1. Okay, so it's going to be 1 minus I squared, so it's going to be 1 plus 1 down the bottom. Okay, so it's going to be 2. Okay, and so that equals, just to simplify the top line, and it's going to be 2, that's the real number there, plus root 3. Now this I squared will be negative, so the real part will be 2 minus root 3. Okay, so that's the real part, and we'll just put those in brackets so you can see the real part. What's the imaginary part? The imaginary part, so the imaginary part is 2 plus root 3. 2 plus root 3. That's our imaginary part, and that's all over 2. So if you can write it like that, or you could probably write it as 1 minus root 3 on 2. That's the real part, plus the imaginary part be 1 plus root 3 on 2. That perhaps might be the cleanest way of writing it, but it just depends on how you're asked. If you're asked to write it as A plus BI, then you'd write it like that. Otherwise that's fine. And so that's just a bit more of a technical example of a more harder division. Oh, yeah, that's the last thing I wanted to do. I just wanted to do modulus, talk about what the modulus of a complex number is. It's also called the absolute value of Z. And quite simple, if Z is equal to A plus BI, then your absolute value, and it's written like this, or your modulus, is just equal to the square root of A squared plus B squared. Okay, so that's our formula there. If you've got Z equal to A plus BI, the modulus is simply using Pythagoras, A squared plus B squared, the square root of that. Quick example, I'm not going to dwell on this. If Z is equal to 2 plus 7I, then the modulus of Z is just the square root of 2 squared plus 7 squared, which is square root of 4 plus 49, so that's root 53. And that's your answer. So that's the modulus. Thank you very much. See you soon.